Thanks so much. All right, everyone, I'm Alex, and today we're going to smash our way through some GitHub organizations. So I want to start by qualifying what this talk is and isn't about. This is not a talk about gaining access to GitHub. We're going to assume that maybe we found a GitHub token laying around somewhere. Maybe we've compromised an engineer laptop. That engineer has access to GitHub. Maybe you've compromised an application that's got some permissions on GitHub. Somehow you have some GitHub access. This is also not a talk about what to do once you've pivoted into a cloud environment or some other kind of managed service. This is a talk about what happens in between. How can you translate GitHub access to cloud environments or whatever other kind of service you'd be interested in that has some kind of integration with GitHub. All right. I also just want to point out that this is like an intermediate level talk. There's nothing technically difficult or complex about what we're going to talk about. It's all straightforward and simple stuff. But we are assuming that you're familiar with CI/CD pipelines, Terraform, things like that. Okay. Cool. So quick rundown of the agenda. We're going to start with a brief introduction to CI/CD attacks. We're only going to scratch the surface here. Very simple, straightforward stuff. But then we're going to kind of wonder, like, if we're targeting a very large organization or maybe even a GitHub enterprise with multiple organizations, we're going to face a bit of a needle in a haystack problem. All right. So how, in that situation, do you find the repositories that you're interested in that you can exploit? And to do that, we're going to build a graph, shove all that in a graph database, and then we're going to query some attack paths. Cool. All right, so let's actually get started with the real stuff, CI/CD attacks. Quick overview of this section. We're going to start by discussing secret exfiltration from CircleCI and GitHub Actions. Does anyone here actually use CircleCI or has used in the past? Okay, there's some CircleCI users, quite a few. Okay. I was hesitating. I thought I would maybe cut that out of the talk, but I won't since there are some CircleCI users here. So we'll start with secret exfiltration from CircleCI and GitHub. Then we'll see how we can attack some Terraform plans. And then we'll look at a couple of tips and tricks. These attacks all have one thing in common. The only thing you need to do to pull them off is be in a position to open a pull request. So assuming you can open a pull request against the right repositories, you can pull these attacks off with some caveats. All right. So CircleCI Contexts. So we have some CircleCI users here. You guys probably know what CircleCI Contexts are. Actually, for both GitHub Actions and CircleCI, there's like two ways that you can manage secrets. Okay. So CircleCI, one of those ways is to use contexts, and contexts are essentially a way to bundle environment variables. Just a heads up, I'm going to use the words environment variable and secrets interchangeably for the rest of the talk. Okay. So context in CircleCI is a way to bundle secrets and reuse them across projects. And let's take a quick look at what this looks like on the web panel. All right, so this is the organization settings, and you can see here we have 3 contexts defined. Among the people familiar with CircleCI, can you tell me what's wrong with this picture? Anything that strikes you as probably maybe bad? All right, so we have 3 contexts here, and you can see that there's a security column. And the security column tells you which members of the organization can access this context, okay? And when you see where it's all members, as you probably guessed, this means all members of the organization can access this context. And if you see something else, that means that it's restricted to one or multiple teams, okay? So in this case, the front-end context can only be accessed by the front-end team. All right, and we see down here we've got an org context, as the name indicates. This is probably intentionally accessible to all members of the organization, but here we have an admin context, and this is probably not intentionally accessible to all members of the organization. So why can this happen? It's an unfortunate thing with CircleCI, is that anyone in your organization can come and create a context and add environment variables to a context, but only a GitHub admin can come and restrict those contexts to a specific team, which is quite unfortunate because either a couple of your GitHub admins are going to spend their days juggling context permissions, or you're maybe going to write some automation to do this, which means that you're giving a service GitHub admin privs, which is also not something you probably want to do. So cool. I don't know if I actually have secrets configured. Let's go and look at front end. All right, here we have a secret token in the front end context that is restricted to the front end GitHub team. So if you're a member of this team, you can pull this token out. All right. That's CircleCI context. An interesting thing with CircleCI as well is that there's no concept of branch protections for secrets. You can pull those secrets whichever context you're running your job in, whether it's after a push to a main branch or a default branch or production branch, or whether it's just a PR feature branch or anything really. So these may have team restrictions, as we said, and here you can't really see this very well, unfortunately. But this is just a basic config.yaml that would show you how you can exploit this. So here we're defining a job that we've called exfil creds. We specify that job is going to use the front-end context. And here, all this job does basically is export the environment variables and post that using curl to an endpoint over the internet. Okay. So depending on where this is running, like you may not be able to exfiltrate things like this. Maybe people are using self-hosted runners. They're running in an environment with some tight egress controls. So you may have to get a bit more creative to exfiltrate these secrets. But chances are, like, if you're running arbitrary code in a build, you can probably find a way to exfiltrate secrets, even if it's just like encoding them and pasting the output and then just reading the log output and decoding the secrets. Cool. So that was CircleCI Contexts. CircleCI Projects, pretty similar, but instead of like reusing these across projects, this is a way of attaching secrets to a specific repository and then having those accessible to the repository. So let's go look at these. All right, so here we have our CircleCI pipelines. Let's look at this project called AWS Infra. So there's a one-to-one mapping between projects and repositories. So there's an AWS Infra repository in GitHub. If we go look at the project settings, environment variables, okay, we have a secret token here. Another thing to note that's quite interesting with CircleCI, and this is relevant for something I'm going to demo a bit later, is we can actually get the last 4 characters of our secret or environment variable out of CircleCI. This is just quite useful, and we'll see in a bit where that may be useful. All right, so pretty straightforward, but again, there's no concept of branch protections here. And here, to exfiltrate these secrets, all you need to be able to do is open a PR. If you can open a PR against the repository, you can get whatever secrets are configured there. And very similar here, we can just exfiltrate these by exporting the environment variables and posting them to an attacker-controlled endpoint, or maybe you have to get a bit more creative depending on your environment. Cool. So that was CircleCI. GitHub Actions. The line is a bit blurred between what's GitHub and GitHub Actions. It's all kind of the same now. But GitHub has 2 ways of attaching secrets to a repository. The first way is very straightforward. It's the original way, the one that was around since GitHub Actions was launched, and that's repository secrets. So let's go check this out. All right, here I have a fake GitHub organization we're using for demo purposes. And I think it's this one, console SPA. Let's go look at the settings, secrets. All right, so I'm going to ask you to ignore environment secrets for a second here and just look at repository secrets. So repository secrets directly attached to a repository. And very similar to CircleCI project environment variables, there's no concept of branch protections here. And if you can open a PR, then you can pull those secrets out. And here we have a sample of a GitHub action config. Exactly, pretty much the same idea, except you need to change the way you're getting your secret out. It's no longer exposed as environment variables. It's going to be in kind of this like secrets object. Cool. The second way you can get secrets in GitHub Actions is to use environment secrets. And this was launched relatively recently, I think about a year ago, December 2020, if I'm not mistaken. And this actually introduced several ways that you can protect your secrets and make sure that they're only accessible to some specific environments. So here for this repository, we have 2 environments defined. We have a prod one and a dev one. You can see that they each have 1 secret. If we go into our secrets here, we can see that there's a dev secret token in the dev environment and a prod secret token in the prod environment. And like I said, this does offer some ways that you can protect your secrets. The one that's particularly pertinent and interesting is this deployment branches one. You can think of this as branch protections for your secrets. So you can restrict secret access to, say, pushes to your deployment, so to your production branch or your main branch or your default branch or whatever. You can restrict production secrets to those events. Cool. So in this case, PR may translate to secret access, depending on how lucky you are. I should point out that, as you can see here, configuring this is totally optional. So you may very well find that some places and some teams are just not using these protections because you actually have to go out of your way and do it. Cool. Something a bit different now. We're going to talk about Terraform Plans and how we can abuse these. Running plans on pull requests is a bad idea, but it's something that a lot of people want to do. And the reason people usually do this is they kind of want to see like how a changes to Terraform are going to affect an environment once they're merged in. And for that reason, you may think that it's a good idea to run a Terraform plan on unreviewed code in a pull request and then say, hey, this is what the plan is going to do to your environment. All right, but there's a problem with that, and the problem with that is that if you're familiar a bit with how Terraform works, Terraform is actually going to refresh its status or its knowledge of your environment when you run a plan, and that means it has to have access to your environment. So Terraform has access to your environment when you're running a plan. So how can we abuse this? Let's go and look at some infrastructure as code here. So we have this repository called GitHub as code. I'll make this a bit bigger maybe. Cool. So if we just go check the pull requests here, this thing, make change, and if we expand this, we can see, all right, clearly we're running some Terraform plan on a pull request, okay? Now let's go and check what this Terraform is doing. All right, here we have our main.hcl, and we can see that we're using two providers here. We have an AWS provider and a GitHub provider. As you probably guessed by the name, the idea here is that we're managing GitHub as code with Terraform, which could be a good idea in some contexts. And here, what are we doing with the AWS provider? You can see that we're pulling a secret called GitHub token out of AWS Secrets Manager, and then we're passing that token to the GitHub provider, and that's how we're authenticating to GitHub. All right, so where can this go wrong in a plan? Well, you can leverage that access to GitHub, or you can exfiltrate the GitHub token. And how would you do that? Here's an example of exactly how you do that. There's a thing in Terraform called the external data source. So you can use the external data source in Terraform if you want to interface between Terraform and an external application to get some data that you then want to use within your Terraform. If that means nothing to you, what this essentially means is that you can run arbitrary scripts in Terraform, okay? And here we're running a script that we passed with this PR, that we added with this PR up here. And we're calling the script, and we can also pass some stuff on standard input to the script. And in this case, we're passing the GitHub token to the script, okay? And here, what are we doing? Well, we're reading information from standard in. We're also getting the environment variables, because why not, while we're at it? And we're posting all this to an attacker-controlled endpoint over the internet, all right? And just like that, we exfiltrated the GitHub token, also anything else that happened to be in the environment variables. And this is why you shouldn't do plans on Terraform pull requests or where they can be dangerous. This is actually maybe not the best example I could have given. So let's think about another scenario here. Let's say that you have a Postgres database that is in a tightly controlled environment with tight egress controls. And one of the only things that can hit that Postgres database is your CI/CD runner. Because maybe you want to manage that database as code, which is, maybe a good idea as well. But in that case, your Terraform actually has access to the database, all right? It's managing that database, so it has some kind of access to it. So by opening a pull request, you can maybe just start reading customer data out of the database and then exfiltrate that somehow, okay? So that's why running Terraform plans on pull requests is a bad idea. A little pro tip here. If you are doing this in an offensive engagement, you may want to consider opening draft pull requests. Draft pull requests will typically trigger CI/CD pipelines, but they won't alert repository maintainers. So a lot of teams these days, they'll have integrations on Slack. If someone opens a PR on the repository, boom, they'll get an alert. Not an alert, but a notification, and they'll maybe go check out what the PR is about. So you probably want to fly under the radar if you're doing some kind of red team or whatever. So consider opening draft pull requests if you're doing these shenanigans. Cool. Like I said, this is only scratching the surface of the kind of things you can do with this. GitHub Actions has received a lot of attention recently, so here's a couple of blog posts you may want to look into if you're into GitHub Actions. But there's also a lot more than GitHub Actions. If I was bored and I was looking for a research project, what I'd probably do is I'd list all the common CI/CD integrations that people are using these days. Maybe look at the integrations that your company is using, and then go poke at those, because I think this is a very under-researched area, and we're plugging everything into GitHub these days, and things are going to go really bad at some point. Cool. So a quick recap of this first section. We see that we can often pull secrets out of repositories or CI/CD systems just by opening pull requests. In a lot of modern environments, it's very common to just give a bunch of people permissions to open pull requests, because it's all about collaborations, and you have to help other teams and fix each other's bugs and everything like that. We've also seen that production Terraform plans on pull requests is risky, or maybe just a bad idea. Draft pull requests don't alert maintainers if you want to fly under the radar. And there's a whole bunch more CI/CD issues that are just not explored here, that I recommend that you explore. And if you're looking for some research ideas, this is ripe. Cool. So now, this is all cool, but let's say you actually want to exploit this. If you're an attacker or you're a defender and you want to find where you have these problems in your organization, you're going to face a bit of a needle in a haystack problem. So back when I was a pen tester, I had a couple of occasions to go free roaming on some very large GitHub enterprises, and I'm talking about 10,000 plus users. They exist, they're out there. Several organizations, dozens of teams, thousands of users, thousands of repositories, and it gets very large and very messy, all right? So how do you go about finding these problems in those situations? Well, I think we're all familiar with GraphDBs. They've received a bit of attention in the security field. There's tools like Bloodhound and cartography out there. So I figured, like, why not just take that idea and use it for GitHub and CI/CD. So essentially, we built a tool that queries GitHub and CircleCI APIs. We're focusing on GitHub and CircleCI because that's what I work with. We query a bunch of data out of the APIs. We massage that data into some schema that makes sense for what we're trying to do. And that gave us our tool, GitOops. I'll show you the repository at the end of the talk. So cool. I'm going to speed through this because it's relatively uninteresting, but I just want to introduce you guys to the schema that we're using here. Hopefully you can see this. So we have 3 users, Alice, Bob, and Cassie. They're members of some teams, and those teams have permissions on some repositories. One thing that I've not illustrated here is that users can also be direct contributors on repositories, so have access to repositories without team membership, without going through team membership. Okay, cool. So users, teams, repositories, we want that information. What information do we want out of repositories? One of the first things we do is we pull configuration files for known popular CI/CD systems. It's like config.yaml or anything in .github/workflows, etc. We also do this for other CI/CD systems, not just CircleCI and GitHub Actions. We also want to get webhook information. So looking at the webhooks that are configured can give you a whole lot of information about what kind of integrations or what kind of magic happens on events to repositories. And we also want to go look at status checks. So status checks are these things that you can see in pull requests. They're actually present on every push, not just pull requests. So we pull status checks for pull requests and pushes to the default branch. That may be extended to support other branches in the future. Cool. As far as GitHub Actions and secrets goes, this is what we pull out. So we pull secrets that are directly attached to repositories, these repository secrets. We also pull the environments for the repository and the secrets attached to those environments. As far as CircleCI goes, we've seen that there's context and project secrets. So in this case, we have Alice. She's a member of the admin team. The admin team has access to the admin context. In our case, we've seen that pretty much the whole organization actually has access to the admin context, but also the admin team. And there's secrets attached to the admin context, but there's also a project, a CircleCI project attached to the repository and secrets attached to the project, okay? So this is basically our schema. The TLDR, not very interesting from a technical point of view, but query a bunch of APIs, massage that data into a GraphDB, boom, job done. All right, now let's look at querying some attack paths. So what I'm going to show you here, we're using Neo4j as our backend GraphDB here. And what you're seeing here is just, I think it's called Bloom, which is the front end for Neo4j. Okay. First query we're going to look at, we're going to say, like, let's imagine that we've compromised Alice, or Alice has been compromised. What secrets? Can you guys see that? Is that all right? Is that good? All right. So we're just going to imagine that Alice has been compromised, and what secrets would the attacker be able to access after Alice has been compromised. Let's run this. Cool. So it looks like there's a lot to unpack. We're going to go through these branches one at a time. There's some labels up here that help you match colors to nodes. First observation here, as we can expect from our query, the central node or the root node is our user, Alice, and the leafs are the nodes on the periphery, and these are secrets. Cool. Let's start with this one here. So we see that Alice has direct permissions on a repository called cQuery, and this repository has some AWS creds attached to it. All right, this is great. So if you can open a pull request against cQuery, you can pull these credentials out. Alice also has access to the Swiper repository, which has 2 environments, dev and prod, and they also have AWS secrets, presumably development AWS secrets and production AWS secrets. As you can probably expect from the dev one, like, there's no branch protections on this one, and this may make sense. Maybe you do want access to your dev environment from a pull request to run some tests. Like, this is a very sensible thing to do. So you can see that the protected branches is set to false down there. We can actually see in this case that there are no protected branches on the prod environment, and that may be a problem. So you could also run a query, like, for example, you wanted to find like all environments that don't have protected branches in your organization. You could do this with this tool. Cool. Let's look at what's going on down here. Alice, she's a member of the organization, so she has access to this org context, which is available to everyone in the organization, and there's a Datadog token there. No big deal. She's also a member of the admin team, through which she has access to the admin context, and from where she can get an Artifactory token. She also has access to the WebSol repository by being a member of the admin team. That has a WebSol CircleCI project configured for it, and there's some GitHub secrets here. Pay attention here that, like I said, with CircleCI, we can extract the truncated value of the secret, which may come in handy. There's also a little interesting story here. This is completely tangential. If you go looking around and you start finding GitHub tokens, often you'll find a GitHub username next to the GitHub token. The historical reason for that is that at some point GitHub allowed you to authenticate to the API with your username and password, and the SDKs were just like developed in a way that made it very clear that you could pass a username and a password to the API. And at some point, obviously, they figured that tokens were probably a good idea. It's like 10 years ago. But those SDKs in some cases look exactly the same. So you have some developers using some GitHub SDKs who think that they have to give a username along with the token, when in reality that's not the case. But the interesting side effect here is that when you start finding GitHub tokens in the wild, if you look around, like you'll usually find a GitHub username next to it. So that's quite cool. And we'll see what we can do with that in a bit. All right, so here we've asked ourselves, like, we've compromised Alice, what secrets do we gain access to? Another question we may ask ourselves, maybe more if you're a defender, or even in the case of an attacker, who do I need to compromise to gain access to something? All right, this is the opposite question. Like here, we're looking for paths between a user and environment variables, where the environment variable contains Artifactory. So here we're trying to figure out, like, who do I need to compromise if I want to gain access to Artifactory and maybe pull off some kind of supply chain attack. Cool. So let's try to organize this as a tree to make it a bit more easy to interpret. Let's get Bob up here, Cassie over here. All right, this looks a bit more like a very ill tree. All right. So we've already seen this path to Artifactory from Alice. Alice is a member of the admin team that has access to the admin context that has an Artifactory token attached to it. And here we've found also that Bob and Cassie, members of two different teams, but what those teams have in common is that they have write permissions on the Monix repository, which has a GitHub repository secret attached to it as well. So that's another path to Artifactory that we've identified. You can also see that this user called FakeBot, as you probably guessed, this is a fake GitHub user. It also has access to the Monix repository. There's another interesting observation here is that, like, as a consultant and as a security engineer, so far in my career, I've never encountered a GitHub organization where there wasn't some fake GitHub users used as bots. That's because there's a lot of limitations and things that you can't do with GitHub apps. So quite often developers just like create a fake GitHub account and use that personal access token for that user as a bot. But these are very useful if you're trying to like move around the organization as an attacker. And that brings us to the next query. Now, a few stars need to align to pull this one off, but I thought I would bring it up because it's quite a fun one to do if you can do it in practice. So we're going to try to predict the access that we can get by pivoting through GitHub bots that we have access to in the organization. All right, and we're going to use everything I just said about GitHub bots, the fact that you often find a username next to a token, and the fact that CircleCI gives you the last 4 characters of your secrets. So what we're doing here is we're looking for paths between Alice and environment variables, where the environment variable looks something like GitHub user, which means it's probably a GitHub username. And we're going to get the truncated value for that. All right, and this is the last 4 characters. All right, then we're going to look for paths between a user and environment variables, where the user's login ends with the truncated value. Oops. All right, does that make sense to everyone, what we're trying to do here? Cool. We're trying to pivot through GitHub bots and predict the access we get. And this is what happens in this case. So we can actually see that starting from Alice, all right, we're starting from Alice, but we see that Alice actually probably has access to a GitHub token. And if she pulled that GitHub token out, then she'd get access to FakeBot. And we know that it's FakeBot because we have the last 4 characters of the GitHub username. And that FakeBot has access to these 2 repositories, which also gives Alice access to Datadog and Artifactory indirectly. Like I said, a few stars need to align to pull this off in a live environment. The reason I bring it up is because I've seen it with my own eyes. Cool. Let's move on to hub repositories. This one's probably interesting as a defender if you're trying to secure a GitHub organization. What we're defining as hub repositories are Hub repositories are repositories that have a large number of inbound relationships. Okay, so the repositories that a lot of people in the organization have access to, usually intentionally, and they're very collaborative repositories. What a hub repository is may vary depending on your organization. Like maybe you're just going to say, like, if 20% of my users have access to a repo, I'm going to consider that a hub repository. Or maybe it's going to be 50%, or maybe it's going to be 100 users, whatever makes sense for your organization. But what we're looking for here is an understanding as a defender, like, we all know that security is not about eliminating risk, right? It's about managing risk. So you maybe want to manage risk around repositories that a lot of people have access to, because there's a high percentage chance that if you face a compromise, one of the compromised users is going to be able to open a PR against those repositories. So we're looking for hub repositories that have, like, here I'm just looking for a token, but it could be anything else that is particularly sensitive in your environment, where the user count is above a certain threshold. All right. The results are not particularly interesting in this case, but we can see that in our case, Monix is a high-risk hub repository, and is maybe a repository that we maybe want to manage secrets differently for it and ensure that we're not giving everyone access to sensitive stuff. Cool. Last example I wanted to show was these Terraform plan attacks that we've mentioned before. So here we're looking for relationships between a user and repository. So users may have direct or indirect access to repositories. So we're looking for up to 2 degrees of separation. We want those repositories to have a status check on a pull request specifically, because a pull request is a requirement for the attack as we outlined it. Where that status check looks something like this. And this is a bit of a funky regex, but essentially what this says is we're looking for things that have TF or Terraform and prod in them, as long as the prod is not preceded by non. So we're looking for things like TF plan prod, Terraform prod plan, anything like that is going to get matched, okay? So let's run this. Boom. So what we see here is that David and Eliza are members of the backend team, which has access to the Flappy repository, and the Flappy repository runs a production plan on pull requests. Maybe something that you want to fix, or maybe you actually want to go see what that Terraform is doing and make sure that it's not too crazy. Awesome. That was it for the examples. Do I have much else to discuss here? Yeah, so this was only like a sample of queries, but I actually had a lot of fun with this, and there's a whole lot more stuff that you could do and may want to look into. You could do pretty banal things like looking for repositories that don't have branch protections but have some kind of CI/CD configured for it. So you could look at like webhooks, status checks, CI configuration files to identify those, and look for branch protections being disabled. I don't think I showed it in the schema. Yeah, I didn't show it in the schema. We actually do pull branch protections configured on repositories. Another thing you may want to do if you're a large organization is audit the indirect access that your external contributors can get. Maybe you work with some contractors who have access to the organization. So you can look for users who are not members of your organization, but who do have access to some of your repos, and make sure you understand the impact of that. You can also go hunting for like who's using legacy CI/CD in your company. Like, is there some Jenkins boxes laying around in the corner? And you can also do some regex matches on CI files if you know exactly what you're looking for. Like we mentioned, there's a couple of footguns with like GitHub actions, so you can maybe go and find those footguns like this. It's maybe not the most efficient way to find those, but it could work. Cool. I do want to give a shout out to my employer, Kaluza. We build a smart energy platform. We're doing smart things in the energy space. They gave me a lot of time to work on this and also supported me in coming talk to you guys here. We are hiring engineers, not just security engineers, all kind of engineers. And finally, I know exactly why anyone comes to a cloud and DevOps talk. So here you go, the pooping unicorns for y'all. I'm Alex K _ALXK on Twitter. Please hit me up. I love to chat about these things. I will show you our repository. If this loads, maybe I'll just type it manually. All right, it's right here actually. Cool. So GitOops, overtext/GitOops. The best name you've ever heard for a hacking DevOps CI/CD tool. I'm quite proud of myself. You can see the README is really quite slick. It's a pleasure to the eyes. Our documentation is also quite complete. Instructions on how to install, build, and run this. Examples, we've got some more example queries over here. Stuff not covered in the talk. Our schema is fully documented here if you want to understand exactly what we're ingesting and how it's connected to other components. blog post that pretty much covers the topic of this talk. And that is it from me. I would be happy to take any questions from anyone.
Thank you, Alex.
Thank you.
If you'd like to put your hand up for questions, I'll bring the microphone round.
Really great talk, thanks.
Thank you.
What I see a lot these days, people using GitHub and CircleCI to try to manage monorepos. Is it even theoretically possible to secure a monorepo using the built-in secret management of those platforms?
Yeah, that's an excellent question, and it's one I don't want to comment on because I have no experience with monorepos. So it sounds like it would be a great blog topic because I have no clue how you run a monorepo at scale. Sounds crazy to me. Anyone else?
Getting a workout.
Yeah. So I just learned that it's really bad running plan on PRs. What would you recommend doing instead?
Yeah, not running plans on PRs. But there's actually, and actually in our company, we've actually done some work towards safely running Terraform plans. I'll tell you this much. There's going to be blog posts. So actually, if you go check out our blog, if you type Overtech on Google, you'll find our blog. There's one article that explains how we do this for infrastructure CI/CD. And actually, sorry, there's the blog post that's going to be coming out soon explaining how we do this safely. I'll tell you that it's contorted. It's not fun. Developers will probably complain, but it is doable.
Thanks.
Great talk. Thanks, Alex. Have you tried doing any of this against Azure DevOps and its GitHub repos or things like that?
No, I'm told.
Would you like
to? Would I like to? Yeah, sure. Is this a job offer? What I can, so I have heard from people more in the know than me that basically GitHub Actions is like rebranded Azure DevOps. Maybe a lot of the same foot guns are around there, but I don't know. I have no experience.
Any more?
What's the worst setup you've actually seen in the wild or on a company you've done some kind of pen test for?
Yeah, so my consultant days are a few years old. Like, full disclosure, I've actually had this tooling idea in man for about like 3 or 4 years, dating from some of my last pen tests. But I would say it's pretty much the things I've discussed here, except at a massive scale. Like, the way we've just like started adding integrations without any thought or any concern for security, is really, it's everywhere. And obviously the bigger and the older the company is, the worse it tends to be. There's actually an awesome quote that I tried to fit it in this talk. Do you guys know who Robert Heinlein is? He's the guy who wrote Starship Troopers. If you've not watched that movie, you should go watch it and then read the book. Excellent stuff. Very relevant themes to today's political climate. But the quote he's famous for is saying that progress is made by lazy people looking for better ways to do things. And I think that very much summarizes everything you see in DevOps. So you can just imagine very smart, very bright people, but very lazy people who just got fed up with manual deployments and everything like that. And I think that explains why there's almost no concern for security in CI/CD.
Thank you. One more, I think, and then we should be on time.
Hi, thanks for the talk. I just wanted to ask, I don't know if you said it already, how you populated a Neo4j database? Like, you navigated through the pipelines and GitHub?
Yeah. So, sorry, what's the question specifically? I maybe did a very poor job at explaining this, but we basically wrote this tool, GitOops, that queries GitHub and CircleCI's API and massages all that into a graph database. So I didn't show you the populating step because it's very boring. It's just going to a terminal, do an API request and massaging stuff into a DB. But yeah, that's the answer.
And what kind of access do you need for that?
Yeah, that's a very good question, actually. So if you're a defender, like, try to get your org admin to give you temporary admin access to run this, and then you'll get the omniscient bird's eye view where you can see like everyone's permissions and do these queries. If you're an attacker, you can still get most of that information, but from your perspective. So you're limited to what you can see. So if you don't have like access to some repositories, then you're not going to see who has access to those repositories. So you need like maintainer or admin access to a repo to pull that information out. But then like in CircleCI, the permission model is pretty weak. So you can get a whole ton of information about the entire organization. So yeah, the answer to that is you can run the tool both as a member or as an admin. You'll just see a lot more as an admin.
Thank you. I think that brings us just up to time.
Awesome.
Thanks
everyone.
Very much, Alex. That was an excellent presentation.